All right, welcome back to lesson 5.2, solving systems by substitution. So in the previous video, we did a little introduction of substitution using some Facebook puzzles. And now we're going to jump into what does this look like mathematically. So the steps we used in the puzzles pretty much match the steps that are used in substitution. You can find these same steps in your textbook in chapter 5, section 2. They are at the top of page 224 in the core concept box. Step 1 being to solve an equation for one of the variables, and then substitute whatever that expression or value from step 1 is into the other equation, and then solve it for the remaining variable. And then take that variable that you have and put it back into the original equation to get the actual value for the first variable. And then I added step 4, check the solution in both equations and make sure that the answer that you have actually works given the two equations or the system of equations that you're solving. Simple little math errors like dropping a negative sign can usually be caught at that point so that you don't miss any questions. Anyway, so we're going to look at the very first example number 1 on page 224, and hopefully this will help you connect what we actually do with the way that those steps are worded. So in example number 1, we're kind of starting off kind of easy because step 1 has already been done for us. We already have y equals negative 2x minus 9. So that equation is already solved for the y variable. And so if you notice, that y is equal to the negative 2x minus 9. So we don't have to actually do step 1, solve one of the equations for one of the variables. It's already done there. Our second equation, 6x minus 5y equals negative 19, is the equation that we would then substitute. So we're doing step 2 now. Substitute the expression from step 1 into the other equation. So notice all of these pieces, negative 2x minus 9, everything that's on the right side of the equal sign is what represents y. Y is equal to that thing. And so we can take that expression and we can put it into the second equation in place of y. Just like when we found out that a sock was worth 5, we could substitute 5 in wherever we saw the sock. Now we can put negative 2x minus 9 in wherever we see y. So our second equation now becomes 6x minus 5 times negative 2x minus 9. And that negative 2x minus 9 is in parentheses, so that 5 has to be distributed through all of that. And it's still equal to 19. So I just dropped down my 6x, and now I'm addressing distributing that negative 5 through the negative 2x minus 9. And so I have negative 5 times negative 2. Negative times the negative is a positive, so I get a plus 10x. And then negative 5 times negative 9 is a positive 45. And that equals still my negative 19. So now I have 6x plus 10x plus 45 equals negative 19. This 6x and this 10x are like terms. They're both a coefficient with an x variable. And so I can add those two together. 6 plus 10 is 16. So I get 16x plus 45 equals negative 19. All right, so now we're ready to start getting the x isolated by itself. So I can use the subtraction property of equality, minus 45 from both sides. And that leaves me with still 16x on this side, the left side. And my right side is, let's see, 9 plus 5 is 14. Carry the 1, 4, 5, 64. So negative 64 on the right side. So I get 16x equals negative 64. So now I'm going to use the division property of equality. I'm going to divide both sides by 16. Pull out my handy dandy calculator. 64 divided by 16 is 4. So my x equals negative 4. So if I think about this as the point where these lines are crossing, I have an x value of negative 4. I'm still not sure what my y is. I don't have a y yet. So I have to now do step 3, substitute the value from step 2 into the original equation. Now could I put 4 back in for this x in 6x minus 5y equals negative 19? Absolutely. You could substitute that into the equation that we just finished using. But if we made a mistake, mathematically, it's more likely that we're going to continue making that mistake if we put it back into the same equation. So it's always best to put it into the other equation. And in this case, it's already solved for y, so that's going to make the math easier anyway. So I have y equals negative 2x. So instead of x, I'm putting my negative 4 and minus 9. So y equals negative 2 times negative 4 minus 9. Well, negative 2 times negative 4, negative times a negative is going to give me a positive 8 minus a 9. So my y is going to equal 8 minus 9. So I'm going to be at negative 1. All right, so our solution, negative 4, comma, negative 1, should be, if we were to graph these two lines, should be where those two lines intersect. Now, as we've discussed before, we should always check our solutions. And wait, I forgot. Negative 4, negative 1. So negative 4, negative 1 is our solution. So we should substitute the negative 4 in for x and the negative 1 in for y. And we should have a true statement in each of these equations. So y equals negative 2x minus 9. I put negative 1 in for the y and negative 4 in for the x. And I get negative 1 equals negative 2 times negative 4 minus 9. Now the big mistake people make here is just putting the first coordinate in for the first variable and the second one for the second variable, but you have to make sure that negative 4 goes in for the x and negative 1 goes in for the y. Otherwise, you won't end up with the right answer. So negative 1 equals, so negative 2 times negative 4, negative times a negative is a positive. 2 times 4 is 8 minus 9. And so positive 8 minus 9 gives me negative 1. Negative 1 is equal to negative 1. So that equation checks out. But we're not done. We have to make sure it works in the second equation as well. 6x minus 5y equals negative 19. So I put negative 4 in for the x. And I put negative 1 in where the y is. And I get 6 times negative 4 minus 5 times negative 1 equals negative 19. So 6 times negative 4, 6 times 4 is 24. And since it's a positive times a negative, I get negative 24. 5 times negative 1 is negative 5, but I'm minusing negative 5, so that gives me a plus 5. And that equals negative 19. Negative 24 plus a 5. So basically, a reminder here, we're on the number line at negative 24, and we're going in the positive direction, 5 hops. So we're going 1, 2, 3, 4, 5 hops to the right on the number line. So if this is negative 24, we're at negative 23, negative 22, negative 21, negative 20, negative 19. So I've got negative 19 equals negative 19, and that checks. So negative 4, comma negative 1 is the correct answer for the system of y equals negative 2x minus 9 and 6x minus 5y equals 19. All right, so at this point, you should be ready to do the monitoring progress problems, numbers 1, 2, and 3 on the bottom of page 224. Don't forget to check your answers, and don't forget that when you write your answer, it should be in the form of coordinates of a point on a graph. So it should be in x comma y form, because it actually represents where those two lines cross on a graph. So go ahead and pause this video right now, take a minute or two, and do those 3 practice problems. All right, welcome back. I hope you took the time to do those practice problems. So what you should have gotten as a result for number 1 was negative 2 comma 8. So x is negative 2, y is 8. For number 2, you should have gotten x is 1/2 and y is negative 3/4. And for number 3, you should have gotten negative 1 for x and 1 for y for the coordinate negative 1 comma 1. Now, number 2 is a little tricky. So let's go over that one because it had some fractions in it, and I know how you guys love fractions. So the 2 equations are y equals 1/2 x minus 1 and 3x plus 2y equals 0. So once again, the first step's already done. This first equation is already solved for y. Y is the same as 1/2 x minus 1. So I should be able to put 1/2 x minus 1 into the second equation in place of the y. So that gives me 3x plus 2 times y, which is the quantity. So in parentheses, 1/2 x minus 1, close off that parentheses, and that equals 0. So 3x plus 2 times 1/2 x minus 1 equals 0. Now, you guys struggle with fractions. Every time we do something with fractions, you freak out. So remember that when we're multiplying, it's top times top, bottom times bottom. So we have 2 over 1, because remember there's this like imaginary 1 under that 2, and I'm multiplying that times 1/2. So that gives me top times top, 2 times 1 is 2. Bottom times bottom, 1 times 2 is 2. So 2 divided by 2 is the same as 1. So 2 halves, 2 times 1/2 x is going to give me 1x. And that should make sense, because if I have 2 halves, I have half, you have half, we put them together, that gives us a whole x. And then we have 2 times negative 1, which gives us negative 2. So 3x plus 1x minus 2 equals 0. So we have some like terms we can combine here, that 3x and the 1x. 3 x's and 1 more x gives me 4x minus 2 equals 0. So now I can start to isolate the x and get rid of everything else. So additive property of equality, add 2 to both sides. 4x equals 2. Divide both sides by 4 using the division property of equality. and I get my x equals 1/2, or it says 2/4, which reduces to 1/2. So if I think about this in the form of coordinates again, my x is 1/2. I still don't know what my y is, but I've done step 2 and I've solved the resulting equation for one of the variables. Now I have to do step 3, put the 1/2 back in for the x, and solve the first equation for y. So I have y equals 1/2 x, so that's going to be 1/2 times my x, which is also 1/2, minus 1. So again, when I multiply fractions, top times top, bottom times bottom. So 1 times 1 on the top is 1, but 2 times 2 on the bottom is 4. So I get y equals 1/4 minus 1. So we can't subtract a fraction from a whole number very easily. We have to turn that whole number into fourths, so it makes us easy to figure out how many fourths we have left over when we take one whole away from 1/4. So if we think about a whole in the terms of fourths, if I have 4 on the bottom and I'm equal to 1, I have to have 4 on the top, which means I have negative 4/4. That's the same as negative 1. So if I have 1/4 and I'm taking away 4/4 from that, if we think about this again on the number line, I'm right here at 1/4, and I'm taking 4/4 away from that. So I'm going to the left in the negative direction, and I'm going 4/4 away from that. So I'm bouncing down 4 times. Each one of these bounces is 1/4. So this would be 1/4 minus 1/4 is going to be at 0. And then the next one is going to be negative 1/4. And then negative 2/4. And then negative 3/4. So I'm going down a fourth, down a fourth, down a fourth, down a fourth, and I'm subtracting 4/4. When I subtract 4/4, what I have is negative 3/4. So y equals negative 3/4. And so our coordinate is, my stylus is not working very well here, negative 3/4. So 1/2 comma negative 3/4. All right, so we'll go back to those solutions. Negative 2 comma 8, 1/2 comma negative 3/4, and negative 1 comma 1. And if you checked your answers, all of those should have been correct.